Hello. In the previous lecture, we started circuit switching, and in this lecture we will study the next type of switching, that is packet switching. Now let's see some disadvantages for circuit switching. Basically, the circuit switching was designed for voice communication, because what happens in voice telephone communication, you just set up initially a link between the sender and the receiver, and that link is exists till the communication ends. Okay, but for non voice transmission, circuit switching is not suited. That's the first problem, is because the non voice communication tends to be bursty. That is, sometimes the data is very heavy, and rest of the time the line is idle. So if it is circuit switching and the line is established, then only for a few time the line will be used, and rest of the time it will be idle. So circuit switching does not work good. I mean, the efficiency of circuit switching would be reduced if it is used for non-voice transmission. That's the first disadvantage. Secondly, the circuit switching assumes single data rate for the sender as well as the receiver. It just considers the link as a single wire. So that gives rise to the third disadvantage, that it is inflexible. So once the circuit has been established, the same circuit has to be used for the remaining communication, irrespective if it is the most efficient one or if it is the least efficient one, or is it available or not available. Once the circuit is established, that same circuit has to be used for transmission. That was the third disadvantage. And the fourth disadvantage for circuit switching, that it treats all the communication or all the transmission as equal. So there is no scope for priority. So the solution was to go for something called as packet switches. So here in packet switches, the data is transmitted, it's broken down into small packets. The length of this packet could be variable. The maximum length of the packets depends on the transmission medium. Longer transmissions are there, they are broken into multiple packets. So one message could be broken down into multiple packets and sent over the network. That is your packet switching. And this packet will not only have data, it will also have some control information, like the header. Maybe the header will have some priority, or it can have a source or the destination address. And these packets are sent from node to node. Okay, next is the datagram approach. So this packet switching is divided into two types. One is datagram approach and second one is virtual circuit approach. In datagram, what happens? In datagram, each packet of a message is treated independently, and that packet is called as a datagram. Now, for example, in the following figure, A wants to send to X. A wants to send 4 packets, and all this A wants to send some message to X. Now, this message is broken down into 4 packets, and they're numbered 1, 2, 3, 4. That is the sequence in which the message is divided, and that's the sequence in which the message should be received by the receiver at X. But if you see in that in the datagram approach, each packet is treated independently, and the packet is free to move or free to take different parts between the nodes in order to reach the destination. They don't have to follow a single path. As a result, what happens is, at the receiver, these datagrams might be received in out of order. So it is receiving out of order at the receiver. So it is the responsibility of the transport layer to actually reorder these datagrams before it sends to the destination port. So you can say, in a sense, that circuit switching works at the physical layer, and the packet switching works at the network layer. So next is in the datagram, if you see from node 1 to node 2, okay, there is only one channel which is carrying packets from A. Okay, the packets 1 and 3 are going in one direction. But if you see the link between node number 2 and 4, there are two channels, and both of these channels are actually carrying two packets from two different sources and the same direction. Whereas from 4 and 3, there are datagrams which are moving in opposite direction. So you can have multiple channel on a single link between the two nodes. That's also possible in datagram approach. Next, in the packet switching is your virtual circuit approach. So what happens in virtual circuit approach is the relationship between all the packets of a single message is preserved or maintained. So what we do is we choose a single route between a sender and a receiver at the start of the session. Once that route is selected or chosen, all the packets will take the same route to the destination, and they will move one after the another sequentially. So there are two different approaches in virtual circuits. First one is called as a switched virtual circuit or SVC. Second one is called as permanent virtual circuit or PVC. In switched virtual circuit, the virtual circuit will exist whenever it is needed and will exist only for the duration of the exchange, and then it gets terminated. So this in switch virtual circuit, there are three phases. The first one is the connection establishment. So if A wants to send some data to X, A has to send a message to X for connection establishment. And if you can see, now there is a connection established from A to X via nodes 1, 3 and 4. Next step is the data transfer. Now, since the link has been established, connection has been established, the virtual circuit has been established between A and X. Now the entire data, that is the 1, 2 and 3 packets of a single message, are sent sequentially over the same route to X. So they are following the same route and they are reaching sequentially to the receiver. Then the last is when the data is finished, when X has received the last packet, that time there is no need for that virtual circuit to remain, so it is released and it ceases to exist. So this is how your switch virtual circuit works. So in case, see, now whenever the data has been transferred, in the data transmission, in the data transfer, at some point of them this link gets broken, then they can even have a different virtual circuit and then send the data. The next type of virtual circuits are the permanent virtual circuits. So here same virtual circuit is existing between the sender and the receiver continuously. Okay, so there is a dedicated route between the two users, and since there is a dedicated route, you don't need to establish the connection or terminate the connection. So if there are two users who are using switch virtual circuits, they could get different routes every time they try to establish a connection. But if there are users who are using permanent PVC, the permanent virtual circuit, they will always get the same route. The last type of switching is called as message switching. The message switching is normally known better by the term store and forward. So what happens is, in this mechanism there is a node which receives a message, stores it until it finds a route which is free, and then once it finds a route which is free, it sends along the message. Now this is considered a switching technique because there is no direct link between the sender and the receiver. Okay, and what happens is the node receives the message on one part, on one link, and then stores it, and after the route is free, it sends on the other link towards the destination. One thing you have to notice, in message switching, the data, the message is stored on the secondary devices, whereas in packet switching, the packets are stored on the primary memory, that is your RAM. In your message switching, it is stored on the secondary memory. Okay, secondly, the message switching provides high-level network services. Now, the problem with message switching is there is a delay in the process of receiving, storing, and then finding the route. And there's also, since the messages are big, it requires large storage devices. Okay, so with this, we end the lecture on switching.